Good morning, ladies and gentlemen. Rusty, thank you very much for the kind introduction, and I'd also like to thank the Marine Technology Society, Ray Toll, and Jim. Thank you for inviting me to this great opportunity. I'm going to test drive the mic here, make sure it works. How do you hear me now? Can you hear me now? All right, good. So thank you all, and I also like to thank IEEE. In my early days as an oceanographer, I published a few papers doing research at Scripps' Marine Physical Laboratory, and the IEEE saw fit to publish some of my work, and I have to thank them for helping me break some ground in oceanography, and really enjoyed that. So first off, let me talk a little bit about my positions. As Rusty alluded to, I have two jobs, primary jobs. I'm the oceanographer of the Navy, so I report to the head Navy officer, Chief of Naval Operations John Richardson, for all oceanography matters, and I also make the oceanography budget. And my other job is I'm the commander of all operating oceanography forces down in Stennis Space Center. So basically, in the job in D.C., I write my own checks that I cash in down south. Unfortunately, nowadays in the Department of Defense, we're finding that most of our checks are beginning to bounce. So that kind of brings us into this, the theme of our conference and the opportunity and the changes that are occurring. The Department of Defense is seeing significant changes, especially with respect to our budget. But those changes, I think, also present opportunities. And so I'm going to talk a little bit about that. First off, in this slide here, I'm kind of depicting some of these, quote, opportunities. Actually, what I'm really addressing here is a number of these increasing maritime threats. We see China's excessive claims in the South China Sea, the melting of ice in the Arctic and opening up of those sea lanes, very provocative actions by Russia on the PRC, of course, Iranians' anti-ship cruise missile threat, all our cyber attacks the department are experiencing, and the declining budgets. All are challenges, but challenges for which we can see as opportunity and force us to innovate and do things smarter with less. Anybody heard of Admiral Sandy Winnefeld? Raise your hand if you heard of Admiral Winnefeld, former vice chairman of the Joint Chiefs of Staff. He just retired, and he had a great quote that he said. He said, "Never waste a crisis." And sort of that's how our Navy is approaching all of these challenges. Is we're learning through them, we're getting better, and we're ensuring we're meeting our mission. And I'll describe a bit about that, but specifically with respect to naval oceanography. The scene setter here in our security environment is that, when you look at how the Department of Defense is drawn down in Iraq, partially, we'll see ISIL kind of is changing the game there, and supposedly in Afghanistan, though the Taliban are also get a vote, and they're increasing their activity. For the most part, we've drawn down most of our forces in that region, but the increasing maritime threats have only expanded and proliferated throughout the world. So, of course, we are all ocean experts here, and we know that 70% of the Earth is covered by water, and about 80% of the world's population lives within 100 kilometers of the coast, and 90% of all trade goes by the sea. And add to that the fact that 99% of all telecommunications is via undersea cable, and so the demand for maritime security it's an imperative, and so the Navy has a job for the foreseeable future. So that's the current environment. Let me talk a bit about naval oceanography, though. That's the focus of my presentation. And our origins really go back to as long as warfare has existed, and that's using the environment to one's advantage to have a tactical or competitive advantage against your adversary. So, for example, in the Battle of Gettysburg, the idea of the Union forces keeping the high ground gave them tactical advantage over the Confederate forces. What we provide the Navy is the high ground for the oceans. Another way to look at it is our Chief of Naval Operations, who just retired, Admiral John Greener. He'd like to say that the Navy is America's away team. So, because we're always deployed forward. Main goal is to deter aggression and prevent conflict from happening. But if conflict does occur, our job is to fight and win. Well, what the Naval Oceanography forces do is we provide the Navy, the away team, home field advantage at those away games. So it's knowledge of the environment and exploiting it, helping us to make better decisions faster than our adversary. You also might like to think of what we do as, if anyone's read any books like During the Age of Sail, like Horatio Hornblower or Patrick O'Brien's novels, The idea of having the weather gauge during the age of sail on the two-dimensional sea surface gave one a tactical advantage in any kind of ships of the line engagement. And so what Naval Oceanography does is we provide the weather gauge from the seafloor out to the edge of space. So it's the weather gauge for the 21st century in that operating environment. So I'll describe that a bit. And this is how we do it. So first off, if you look on the left here, we have a large number of disparate data sources. We have unmanned systems, gliders, profiling the ocean now. We have about 15 worldwide that are underway. We have a number of satellites we use, both Defense Department satellites as well as international satellites and U.S. government satellites. And we have a fleet of 5 oceanographic survey ships, soon to be 6. Looking forward to the delivery of the USN Maury in February, hopefully. And we take all that data and we feed that to these processing and production centers. We have 3 main ones. We have the Fleet Numerical Center in Monterey, California, which does the atmospheric modeling and prediction. We have the Naval Oceanographic Office in Stennis Space Center, Mississippi, that does ocean modeling and database collection. And then we have a thing called the Naval Observatory right here in Washington, D.C., that predicts the motions of the stars and of the planet Earth. Very important for positioning, precise positioning used by GPS and other systems. So those production centers all take that data in, and then they feed it out, they process it, and they look at the impacts of what that information, the predicted environment, will have on warfighting actions. And the way that's conveyed is we have a number of teams. I have a number of commands that all deploy with naval forces for all the warfare areas. So I have a command that's dedicated to ASW. I have a command that's dedicated to naval special warfare, embedding with the Navy SEALs. I have a command that's dedicated to mine warfare. And then I have 2 commands that are dedicated to supporting fleet operations and strike warfare with aircraft carriers. And those teams all go out forward. They're all deployed right now, and they take the information from our centers, and they sit down with planners and operators, and they say, nope, don't use that sensor, or don't take that route. You do this, don't do that, because the weather, the sea state, the ocean currents will have good and bad effects. So we're exploiting the environment right there, hand in glove with naval operators. And that's so warfighting commanders can make the right decisions. Basically, like I said, helping us make better decisions faster than the bad guys. So that's how we do it. And here's some examples of what we've done. It might be hard for all you in the back. I didn't realize we were going to have such a large room, but I'll narrate this very quickly. It's just an example of what we've done during the past year. So our support to the Navy has ranged from very low-end sort of operations where we basically worked with small navies, like this Southern Partnership Station, Africa Partnership Station, and a Pacific Partnership Station. All were efforts to work with small navies in the regions to basically build our alliances. Because when we work, our forces are very suited to small navies. We have our oceanographic ships and other teams. And that's just not as overpowering and intimidating as, for example, an aircraft carrier strike group. So we work with a number of these navies to build our partnerships, and basically that helps prevent and deter conflict or actions from large nation states. So we do that all around the world. On the low end, exercises included, like the Rim of the Pacific exercise, to the high end of conducting strikes against terrorists or, for example, the Islamic State right here. The aircraft carrier George Bush was the very first asset on the scene when the president last year directed us to take action against the Islamic State. There was nothing else available, and so for a period of almost 2 months, the only asset there was an American aircraft carrier with naval oceanographers on board helping plan the strike cycle. And then we had an interesting event was the Syria chemical weapons disposal. I don't know if anybody remembers that last year, but that was a pretty significant national and international level of effort. And what wasn't known or reported in the press is how dependent that was on sea state. We had a ship out there, a military Sea Lift Command ship, and the complex equipment she had to neutralize those chemical weapons that couldn't operate above sea state 3. So precise forecasting was critical to ensure we optimized and completed that operation, and many, many others that I could talk about. But we're engaged in every range of operations for the Navy, helping the Navy do the right thing and work more effectively and do it more safely. All right. So here, let me give you a little anecdote, an example of how the oceans and knowledge of the oceans matters in undersea warfare. Undersea warfare being a very important capability of the Navy today, where we do have a competitive advantage, and we're working hard to keep it. But we have a number of competitors who are trying to overtake it. And one such is the PLA Navy of China. So the anecdote I give it involves an open source report about a submarine commander who was awarded a medal. Because what happened is his sub was operating off his coast, off the Chinese coast, and this sub experienced a thing called an inadvertent depth excursion, kind of technical speak for basically sinking real fast when you didn't want to. And not a good thing if you're a submariner. Raise your hand if you have been a submarine officer on board or on board a submarine. So if you y'all know what this is about, it's not good. and it happened, and we know with confidence it happened because of an internal wave. And it was in the region near the Taiwan Straits where these internal wave features tend to happen. And so what I have depicted here, it's probably hard to see, here's a geographical plot of Taiwan, and here's the northern tip of Luzon. And here you can see the surface manifestation from a SAR image of these internal waves that propagate from east to west. And as they approach the shelf, they begin to break. Here's a a vertical plot that shows the temperature profile of one such of these features. And you see they sort of reside on about 100 meters or 150 meters, or pardon me, about 100 meters, and they're about 200 meters in amplitude. They're huge. They're incredibly huge physical processes. The kinetic energy of one of these is over 10,000 times of the energy you'd see in the open ocean. In fact, when these break, again, 200-meter amplitude, the white water, it's not really white water, of course, but the white water or turbulent field that is produced near the mixed layer depth is on the order of 100 meters. I mean, think about going to the beach and seeing 100 meters of white water coming at you. That's the kind of hazard these features pose to submarine navigation. And again, we did some oceanography CSI, and to backtrack from data sets with ONR and our Naval Oceanographic Office, that right when this incident occurred and was reported, this is what caused it. So here's the clincher. The models I run at the Naval Oceanographic Office can resolve these. We have a little bit hard time predicting the exact phase of them, but we can predict when they occur. We're getting better at that. We're going to incorporate them into alert messages for our submarine force. But we can do this. The South China Sea Oceanographic Institute recently just emailed us just after this event and basically asked us for our Navy Coastal Ocean Model source code. So we know they're watching that and associate it with this activity, but they can't yet resolve it and predict it. And that's why these kind of things happen to them. Very important tactically, you could see. And again, our potential adversaries are working to get as good as we are. But that's a little example of why we want to know and understand the ocean. And our submarine community gets it, and they use this information. Next slide. There we go. So I want to talk a little bit about some initiatives, and then I'll close. New things we're doing. The opportunities for innovation that all these challenges are forcing us to seek. I use this slide as a starter for the discussion because this is an image of one of our supercomputers, and on it we have the face of Einstein you see depicted. I use that because it was an interesting thing in history. You probably know who Lord Kelvin is, very famous scientist of the 18th and 19th century. And in 1900, he was famous for saying, many of you heard this, that we have discovered all there is to discover in science. And now all future discoveries will really be just a matter of making more and more precise measurements. That was 1900. And of course, in 1905, this guy proved him wrong with special relativity. So that's the sort of thing that's what we're trying to in Naval Oceanography always anticipate and be open and ready for is new ways of thinking and potentially new discovery. So one area of focus is unmanned systems, and I'm looking forward to seeing the exhibits. many of you all are involved in unmanned systems operations, especially unmanned underwater vehicles. And in Naval Oceanography, primarily through the Naval Oceanographic Office, but all our commands actually, we have a large field of expertise, people, and years of operation of these systems. We operate all kinds, so unmanned aerial vehicles for naval special warfare. We are the Navy SEALs' lead operators for their UAVs, as well as their unmanned underwater vehicles that do hydrographic reconnaissance. We also operate unmanned surface vehicles and UUVs for hydrographic survey. And we're supporting not only the SEALs, but mine warfare forces in the Gulf right now and in Korea, as well as anti-submarine forces worldwide. And so we're using all these systems, and we've developed them and are working to operate them in concert with public-private partnerships, different labs. Here you see an image of FLIP. I worked at the Marine Physical Lab, as I told you earlier, and universities in partnership, all to get better at operating these. And we've just released a strategy, and the goal is very simple. It's that we would like to help the rest of the Navy get on step, accelerate their development, acquisition, and operation of their unmanned systems, because we have so much experience. And it's going to happen. It is happening today. A number of the Navy's new platforms all have plans or already are operating diverse unmanned systems that weren't around a decade ago. Fire Scout UAVs, for example, are going to be employed on every LCS, Littoral Combat Ship. They're also going to operate these MCM, Mine Countermeasure mission packages that will all have unmanned surface vehicles, and so on and so on. So we'll see an incredible proliferation within the Navy, within the Department of Defense, within industry of operating these systems. And Naval Oceanography, we have a lot to contribute. Another initiative is environmental modeling. And I know that in the back you're not really going to see all that there is to see, but I'll make two main points about our modeling initiatives, and I think they're pretty powerful. First off is we are leveraging and actually achieving an increase in computing performance that's basically outpacing Moore's Law. So really thrilled about that. We use an asset called the Defense Shared Resource Center down at Stennis Space Center, and it's a DoD-wide, Department of Defense-wide supercomputing asset. Where we're going with our modeling is we're starting to couple the various domains. And this is really, really exciting. Here, the depiction is 2002, 2014, and 2020, where here and today we're just starting to couple the various domains. We just got operational on our ocean and ice coupled model called the Global Ocean Forecast System, and we'll be using that to support a submarine ice exercise in the Arctic in March. But by 2020, we expect to have all domains coupled, and in addition, to run a number of ensemble models that will produce an estimate of uncertainty or probability for various forecasts. So the supercomputing is today allowing us to achieve an ability to model the Earth like it really is. And that is what's so exciting. Is previously we've just we've fudged it, trying to model different domains without any fluxes of energy and momentum and mass. It's just not right. And that's what we've done in the past, but we are getting ready to model the Earth like it is, and it's going to make us better at predicting those impacts the Navy cares about. Okay. Second to last maybe, of our initiatives is we're going to field this new survey ship, which employs a number of off-board and on-board sensors that I bet many of you in the room, or at least the exhibitors, are all contributing to. And the key feature of this ship is it's going to have a moon pool in the middle of it that will allow us to operate unmanned systems during higher sea states, as well as doing so 24/7. And previously, sometimes night operations were either difficult or challenging. And now we can do it all the time with this moon pool feature. So we're very excited to see that. And we're in the stages now to develop the next class of ships and perform a study on that. Okay. Two other items. I see that in this audience you probably have a number of Sea Technology magazine subscribers. And if you can't really get an issue of Sea Technology without some talk of ocean energy. And there's two aspects of ocean energy that are worth mentioning. I don't oversee them as the oceanographer of the Navy, but the Office of Naval Research is funding a number of efforts that I try to keep cognizant of in my job as being the CNO's policy lead for ocean things. And that is, so ocean thermal energy conversion, The Navy and the Office of Naval Research are investing a significant amount through there's a site we have on the Big Island of Hawaii, a test site, and so it's acting as this large site that we're inviting industry and other government agencies to perform the kind of R&D that needs to be done right now to make this viable. And we're just not there yet, but with the Navy's goal, and the Secretary of the Navy, Ray Mabus, has the goal of by 2020, all Navy shore energy will be sourced by alternative fuels. And so we have that mandate. And so the private sector, with a primarily profit-driven model, really can't afford to do all that upfront R&D. So the Navy's kickstarting it. And I think we're going to see a lot of work done. And by 2020, I think we'll have a seed of capabilities that will allow, I think, industry to take this to another level. Another piece of that is wave and tidal energy conversion, and we also have a test site in Kaneohe Bay on the island of Oahu. And the same there is that we're opening it up to help the SecNav reach its energy goals, and we think that's going to provide a platform for the rest of the nation to expand. Okay. So I've talked a lot about some great technology, and the Marine Technology Society, of course, focuses on technology. But let me just sort of conclude by saying that it's not just stuff, it's our people, right? And that's, when we talk about sea change, looking for opportunity, I believe that our people are our greatest opportunity. And that's why we're investing time and money and effort into STEM education and outreach at middle schools and community colleges, as well as recruiting in the same vein, and then fostering programs to retain our very talented workforce. I'll kind of close with a couple of quotes. I talked about the old Chief of Naval Operations, Admiral John Greenert. I was privileged to attend his change of command just a few weeks ago at the Naval Academy, and he was relieved by Admiral John Richardson. And so here are two naval officers with a significant amount of authority and responsibility and accountability, 2 4-stars, and both of them in their remarks really didn't say that much. The outgoing CNO had accomplished a whole lot in 4 years, and he didn't talk about all that he did. And the incoming CNO, he has a lot to do and all those opportunities I talked about in the beginning, those challenges to face. But he didn't talk about that either, not much. What they both talked about was people. Admiral John Greenert said, people are our asymmetric advantage. And he was referring to the well-known, well-documented challenge we face of asymmetric threats, cheap mines, cheap missiles that can take out billion-dollar aircraft carriers. And he didn't talk about all this great technology we're investing in to counter it. He talked about our people being our asymmetric advantage. And then John Richardson followed him, and he said the same thing. He talked about his family. He's got 5 kids, believe it or not, and he's made it up to 4 stars. And he joked and said, my family is kind of proof that quantity has a quality all its own. But then he said, the Navy's a family, and we need to take care of each other like a family. So taking care of people, it was a theme. And he closed with this quote, and I thought it was great. He said, it's getting sporty out there. And he said, this game we play in the Navy, all these challenges and these competitors. So it's getting sporty out there. But he said, I have every confidence that we're going to win in this game, and we'll continue to win, because there is no player more unbeatable than the U.S. Navy sailor, who is at his best when the chips are down, the stakes are high, and the going is tough. And of course, that brought everybody to their standing up and a big ovation, and you just wanted to do a fist pump and high five the guy. And he was right. He was right. But he missed one thing, and this was it. So our sailors are great, and our people are great, and that's what makes us great. But it's also our important civilian partners within our organizations, and it's the work that you all do in industry and academia that really enable us to go out forward to fight and win. So thanks very much. Okay, I think we have time for questions if anybody has any. I stunned you into silence, is that it? Okay, well, great. Thanks for your time. Oh, there is. Hey, Pete, how are you? Old shipmate. That's great.
Great discussion today. What can you tell me about the Navy's oceanographic models and making those openly available to the public?
Well, as you saw, I had some concern about sharing them with some of our competitors, and that is a concern. So we have a concern about that. To retain our competitive advantage that we have today, we believe that we need to retain some of that technology and not allow it to be open and share it with the public. However, we do share various data sets, as you know well. So we have to do a kind of we have to strike a balance between technology that we know gives us an advantage, and then things that we do that we know will somehow can be made available to all that don't really risk eroding that competitive advantage. So it's a balance we strike, as you know. And in fact, but our focus, because of our warfighting mission, is, we do share a lot, but it's primarily through bilateral or some multilateral. That means with other navies that we want to secure as partners and allies in any kind of in any given theater. So information sharing is a very important thing, and it's good to do, and it's enabling. But we have to think really on a case-by-case basis of when it won't, and to ensure it won't erode a competitive advantage. Thanks. Yes, ma'am.
I've been interested in seeing the technologies you showed. What technologies would you like to see developed in the next steps to aid in your missions?
It's interesting. Barbara, thank you for your question. Her question is, what technologies would you like to see in the future developed? And raise your hand if you've seen The $6 Million Man. Okay, great show. Of course, I grew up on that stuff. So if you remember in the beginning, we have the technology. We can rebuild him. So, we have the technology that I want today. My primary concern is getting through acquisition and delivering it. What I'd like, two big areas of focus for me are sensing the boundary layer of the atmosphere to a higher resolution. We're getting the computing power to model it, but I don't have the sensing capabilities. We have the technology. The sensors are there. They're all over industry. But I'd like to get those on every platform. So if you saw on my Unmanned Systems thing and public-private partnerships, I'm starting to talk to Carnival Cruise Lines to see if they would put a weather sensor on. They have weather sensors on their ship, and send that to me. That's just one. But if I can get every platform in person to have a sensor and feed that into my models, I'll be able to model that boundary layer and better predict electromagnetic spectrum performance of our systems. Same goes for the undersea side of the house. There's a lot of things in the water right now, and I'd like to be able to get access to all that data and improve the fidelity of my models. Because the demand I am seeing right now is to improve, and we're good still, but we can get better, is to improve the precision and accuracy of our ocean and atmosphere models. Good question. Thank you.
Any other questions?
Okay. Thanks all for your time.